Okay, here's warm-up number 30. I'm going to describe the end behavior. So I'm going to just look at the leading term here. I'm looking, this has a leading coefficient that is positive. So the leading coefficient is positive. And then the degree, if I'm looking at the degree is odd. Okay, so then I'm just going to think about the simplest possible equation with a positive leading coefficient and an odd degree. How about y equals x? My leading coefficient is positive and the degree is odd. And that I know looks like this. So this will have that same end behavior. So that means as you go left on the x-axis, so as x approaches negative infinity, that's going to the left on the x-axis. We're going to go down on the y-axis. As you go left, you go down. Like that. Okay? And the other part, as I go right, I'm going to go up. So as x approaches, as x approaches positive infinity, y is going to approach positive infinity as well. Okay? So there is my end behavior. All right, how many zeros are there? Well, there are going to be 3. That's the fundamental theorem of algebra. That's because this is a third degree equation. Okay, let's list the possible rational roots. So what I'm going to do here is I'm going to take the factors of negative 10 over the factors of 1. So the factors of my constant over the factors of my leading coefficient. So let's see. All right, factors of 10. Let's see. 1 goes in there, but so does negative 1. So I want to put positive and negative 1 on that list. Okay, I'm going to do that for all of these factors because 2 goes in there, but so does negative 2. And then 5 and positive and negative 10. Okay, pretty sure I got all those on top. Only factors of 1 are positive and negative 1. So here are my possible rational roots. So since I'm just dividing by 1 no matter what, I'm really looking at these integers, 1, 2, 5, or 10, positive or negative. So if there are rational roots, they're in this list, and those are also going to correspond to x-intercepts. There might be other x-intercepts that aren't on this list, but that means they wouldn't be rational, okay? So next thing I'm going to do is factor this. And looking at this, it looks like it might be a candidate for factoring by grouping, but if you try to factor this by grouping, there's not going to be it's going to be a dead end. You can factor out x squared out of the first group, but you won't have matching pieces, and factoring by grouping won't work. Okay. So what I'm going to do instead, I'm going to use some synthetic division to test these 8 different possible x-intercepts, these different roots. Now you could just do the synthetic division 8 times until you find a winner. That could work. Or to save some time, you can graph the function on a calculator and look for x-intercepts that might correspond to these 8 different values. So that's what I'm going to do. So let's see. I've got x to the third plus 5x squared plus x minus 10. Okay, I hit the y equals button to get to this screen. Now that I've got it input, I'm going to hit graph to get a look at the graph. And I'm looking for x-intercepts. So this looks like 1, 2, 3. This looks like negative 4, which isn't on my list. So I'm just going to ignore that one and assume that that's not a rational root. Here, it looks like maybe negative 2. So these are my guesses here. I don't know for sure, but this is just saving me some time so I don't have to go through this whole list, and I can make some educated guesses. Also looks like maybe negative or positive 1. It looks like it might cross at positive 1. So I'm going to try these two out. So let's see. Okay, I'm going to take, see if negative 2 is a root. If it is, I should be able to factor out x plus 2. And I should get a 0 remainder when I do this synthetic division. Okay, and maybe it's not because it might be crossing near negative 2, but it might not be exactly at negative 2. So that's why I need a test. Okay, so I'm pulling that down, multiplying by negative 2, adding, multiplying, adding, multiplying. Hey, that one did work. Okay, so I could actually stop here if I wanted to. So what I've done now, I've got this factored. I could stop with the synthetic division. I mean, I factored out x plus 2, right? And what's left over when I factor that out is this. So this would be negative 5, 3x. This is x squared. So x squared plus 3x minus 5. Okay? What I meant by I could stop with the synthetic division if I wanted, because I've got this down to a trinomial, and I can just see if it's factorable. I could use a diamond problem. Okay? And this one I can actually tell is not going to be factorable. So even though it looked like 1 was a root, I think you'll find that it's not a root. Okay, so I'll just do a really quick little test of 1 up here. I'm going to go, you could use it with this trinomial, but just to show you, if you did the 1 first, you could use it with the original as well. And I'm guessing I'm not going to get a 0 remainder here. Let's see. No, I did get a remainder. So my guess is this one was right, but this one was not. Okay, and I couldn't tell that looking at the graph, but at least I didn't have to try out all 8. I just tried those 2. Okay, so you might want to try to factor the trinomial more just to make sure, but I think you'll find it's not factorable. There is no winning combo here with the diamond problem. No two numbers that multiply to negative 5 and add to positive 3. So this is factored completely. Okay, now find all the zeros. Okay, so to find the zeros, I'm going to plug in 0 for f of x. I'm going to use the factored version. That's the whole point of factoring here. It's going to allow me to find all of these zeros. Okay, one of them I already knew about, x plus 2 equals 0. That means x is going to equal negative 2. Okay, but I should have 3 total zeros. The other 2 are going to come from this trinomial. So let's set this equal to 0. Okay, I know I can't factor this because I already tried. So 2 options left. I can complete the square, or I could use the quadratic formula. Okay, now my choice here is going to be quadratic formula, just because I've got a b, that coefficient is odd, which means when I look for the mystery number, I'm going to end up with fractions. I'd rather not do that. So if that was an even number, I probably would complete the square. But I'm going to use quadratic formula. But whatever your preferences is fine. So I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. So I just left blank parentheses for a, b, and c. So b is 3. It's going to go in those 2 slots. A is going to be 1 in these 2 slots. And negative 5 is c. Okay? And let's start to simplify this. Okay, I've got 9, and I've got negative 4 times negative 5 would be positive 20. Okay, got it down to this. Okay, so 29 is not a it's not a perfect square, and there's no twins in there, right? So I'm going to leave this in simple radical form, which it is in simple radical form. You could do decimal approximations, okay? And so, you know, if you look at the other 2, so it kind of looks like negative 4 and positive 1. And I'm guessing if you put this into a calculator, those 2 other x values are going to be very close to negative 4 and positive 1. So let's just do a little test real quick. Negative 3, whoops. Plus the square root of 29, and let's divide that by 2. So one of those x values was 1.19. That's why I made that guess. That was wrong, but you can see it's very close to one of the roots. And then let's see if I do negative 3 minus root 29, divide that by 2. That's going to give me negative 4.19. So that's why it looked like it was crossing at those 2 places, because it's crossing very near 1 and negative 4. But yeah, let's leave our answers exact in simple radical form. Okay, and now let's sketch a graph. Now I've already graphed it on my calculator, but even if I hadn't graphed it on my calculator, the only reason I graphed on my calculator is so I didn't have to try all 8 of these out. But you can imagine I could have tried them all out and found that the only one that goes in evenly is the negative 2. Okay, and then I could make a decent graph of this using all the information I've collected, even if I didn't have a calculator. Okay, so here we go. Here's my XY graph. It says no y-scale necessary. So that means I'm going to just graph this with the x-intercepts that I found. So I've got one at -2. Okay. I've got one very near -4. I'll just put it right to the left of -4, something like that. Okay. And then I've got one very near +1, just to the right of +1, something like that. Okay. And then I'm going to put that together with the end behavior, which there's a little picture of it. I'm going to start low at the left side. I'm going to end up high. And I'm also going to cross the x-axis at these 3 paces. So I'm going to start down here, and I'm going to end up here. And I'm not really worrying about how high this hill is going to be, but I know I got to turn around to cross the x-axis again, and I'm not worrying about how low this valley is because it said no y-scale necessary. Okay, and there we've got a decent sketch of the graph. You could also find the y-intercept pretty easily if you wanted another point to make an even better graph. Okay, and that's it for today, and I will see you next time.